Hi everyone, I continue on the lesson review 5. Here I want to talk about application of ratio, and I want to talk about golden ratio, which has which is related to beauty of nature. So here we have a body here, and this activity needs you to measure different part of body, and it's I don't say it works for everybody, but it's just very close to and approximately working for all. Okay, so you can do some measure. So here, for example, we talk about arm span, which is from here to here, the first one, and then height, which is from here to here, and then navel height, which is from here to here, and then forearm hand to elbow, so which is from here to here, and elbow and hand, which is from here to here. Okay, so you can do some measurement and find the ratio this way. So this is almost for everybody. If we have this ratio, so we I mean almost for everybody we are going to have this ratio. Okay, and that's why there are some ratio, almost the same numbers related to everybody's part for the same person. Okay, so here we see that arm span and the height must be almost the same. Okay, so it's like 1 to 1. Okay, height and navel height, which is, where is it? So it's floor to body. So the height and this, so it is like 1.6 to 1. Okay, so this one to this one means, you if you just measure height and if you measure navel height, it's like that. And forearm plus hand and arm and forearm, so means, for example, this one and this one. So sorry, you have to change the color. So this one and this one. Okay, so they are like the same, so they are like 1.6 and also to 1, right? So what do I mean here? So as I say, it is almost for everybody and almost close to this number. Okay, so if we measure this part of the body and that part of the body, and if we compare, it's like this number. Okay, and that's a beauty of the nature for just all of our so all of our bodies, so different parts and different measurements. So that's okay. For example, we can have height the same as, for example, we can have height the same as 187, for example, centimeter. Of course, this is not my height, so no, I'm a short person. So, and just this one as the so for example height, and this one is the navel height. Okay, so 115 centimeter. Okay, so if you find 187 to 115 centimeter and centimeter cancer, then you see the answer is 1.6260, and then we can continue. See, it's very close, so it's not really exactly the same, of course not, it's approximate. So approximately it is like 1.62621, and we say approximately this is for so this is almost for everyone, for these, when you compare this part of body size. Okay, and that's a beauty of nature. So for example, if someone is short, of course the height is shorter, and also the navel height is also shorter. So if we compare, we reach to the same number. Okay, so what do we call this number? So this number is we call it golden ratio because it's has beauty of the nature, so we call it golden ratio. How do we have it? Okay, so here, if I want to tell you the history of the number, so I have to talk about Fibonacci sequence. Fibonacci sequence is, you can search, you can Google. It has something to do with birth of rabbits. Okay, so which start from 1 and 1, and then after we have 2, and after we have 1 and 2, so we have 3. So it's like that. Okay, so every number, so how can I explain the sequence? So every number is addition of two previous number. See, it starts from 1 1, and then 1 1, 1 plus 1 is 2, and then 1 plus 2 is 3, and then 2 plus 3 is 5, and then 3 plus 5 is 8. Okay, see, if I add these two, I have this one, and if I add these two, I have this one, and if I add these two, then I have this one, and then if I add these two, I have this one. So every number is summation of to the previous one. So 13 is 5 plus 8. 8 is 3 plus 5. 21 is 8 plus 13. So 8 plus 13 is, so do I have, yes. Okay, so 5 plus 8 is 13, and 8 plus 13 is 21, and I can continue. Okay, so how do we have that? So you can search and find the sequence. So the sequence is made by, it starts from 1 and 1, and then each number is made by addition of two previous numbers. So you start from 1 and 1, and then 1 plus 1 is 2, and then 1 plus 2 is, so always each number is summation of two previous one. Okay, so if I continue this way, and then I find the ratio of summation of two values, I compare it with the larger one. So it means if I compare a plus b with the larger, which is a, the larger number, okay, so I will reach to almost the same number that I talked about as a golden ratio. Okay, so for example, see, if you do summation divided by the larger number, so I mean ratio of that, so 2 over 1 is 2, 3 over 2 is 1.5, 5 over 3 is 1.66. See, if we continue, we reach to that answer. So 8 over 5 is 1.6. 1.6. How about after 13 over 8? 1.625. How about after 21 over 13? Oops. 21 over 13, which is 1.615. Oops. Okay, as we continue, we can see at the end. So for example, if I continue, I have, for example, when I continue, I can have 144. When I continue, okay, look at that. Do I see 144? Yes. See, look at this. 144. So I just make them blue, and then I go there. So it's 144 over, when I continue, 144 over 89, right? Yes. Okay, which is 1.6179, and I can have some digits. Okay, so, and I can round it. See, it's almost very close to that number I talked about. Okay. So, okay, so exactly like pi, which is 3.14, this that's a constant number, and it's very so important for us in geometry. When we are working with circle, we need to know pi. So right now it's important for us to know phi. Okay, so phi is the golden ratio and the number which has something to do with beauty of body. For example, in a face, if you want to compare different parts, you reach to this number. In body, so so even hands, so you can see it. Okay, also you can start from just Fibonacci and work with this one. See, for example, if you start from 1 1 here, and then you see 2, and then you have 1 2, you see 3, and then 2 3 is 5, and then 3 5 is 8, and then 5 8 is 13, and then 8 plus 13 is 21, and then, okay, so you will see just bigger squares are coming out of these numbers, coming out of these sequences. Okay, and then you will see that's a very beautiful, big, beautiful shape. which is made out of these numbers and out of these sequences. Okay, so you can search, but you can continue to see many beautiful pictures in the nature. They have something to do with this ratio. Okay, with this ratio, with all of these sequences, and if you divide each sequence with the number previous one, you will reach to this answer. You will reach to this ratio. Okay, so for example, even like CN Tower, when they wanted to make it, so they did, for example, the height. For example, the height divided by the bigger part, for example, it has that number. So if we just do research on it. Okay, so that's why we call it golden ratio, and it has application of ratio here, so that you can just do more research on it and learn more. See here in beauty, in pictures, in we can see it in many things. So if we want to have just, for example, a very beautiful picture, beautiful image, for example, we have to consider that ratio. So the next lesson, which is very important, is proportion. Very important for us. With proportion, we can solve many problems. So, for example, I can make you a question, and for example, I can say I have $200 and I can purchase two books, for example. For example, I would say two books, so two the same books. Okay, so now I would tell you how many books I can buy with $500. And for example, the question can be this way, or the question can be, how much should I pay for 5 books? So if I pay $200 for 2 books, how much do I pay for 5 books? Or if I pay $200 for 2 books, how many books I can buy with $200? So these questions, they can come with proportion. And proportion is made by two ratios. Okay? A proportion is equation because I agree and I accept that the situation is the same. I tell you, I pay $200 for 2 books. How many books I can buy with $500? I didn't say I am going to different store. I didn't say I'm going to different country, to different time. Okay, so I say the situation is the same. So that's why I have equal between two ratios. So proportion is equation of two ratios, and it helps me to solve many word problems when I have two situations which are comparing, and for example, two situations which are the same and one of the part is missing. For example, I have $200 and I purchase 2 books. How many books, how many the same books I can buy with $500? The same book. So it means I am talking about the same time, the same country, from the same store. Otherwise, I have to give you more information. Okay? So the questions are like that. So you can solve this question by proportion. Proportion is two ratios in agreement to be equal. So I accept the situation is the same. I accept I can buy $200. I can buy 2 books with $200 means each one is $100. So with $500, of course, I can buy 5 books. Or how much do I pay for 5 books? Okay, if I do 202, so now for 5, I have to pay $500. Okay, so I am in the same condition. I am in the same situation, but two different story. Okay, so two different, just the same situation. Okay, just two different, I would say the same condition, but the same condition, two different situations. Okay, I would say. So a proportion is equation of two ratios which we accept. Both ratios are just the same as each other. Okay, and then I want to find one of them. One of them is missing. Okay, so before I go to word problems and I make it just for you, make it touchable, because when I talk about real story and when I talk about real life situations, then you understand what I'm talking about. Before that, it's harder. So I first of all, I need to maybe just tell you that situation. So, and then I move on how to solve and what is proportion and those things. See, I tell you, I pay $200 for 2 books. Then I tell, with $500, how many books? Or I pay $200 for 2 books. How much should I pay for 5 books? See, I have a proportion, which means I have 2 ratios equal because it's the same condition, but 2 different situations. One of them I have 2 books, $200. One of them I have $500. How many books? Or I have 5 books. How much? Okay. So I write 2 ratios and I write them equal with each other because the condition is the same. But how do I write it? And how do I solve it? So what should I do in this case? I answer all of these questions when I start here. Okay, so write proportion as this, like 3 is to 5 as 9 is to 15. Okay, see, 3 is to 5, 3 is to 5 as 9 is to 15. Is it really? Let me see, is it? This is 3 times 3 over 3 times 5. 3 and 3 cancel. Yes, it is like 3 over 5. Yes, it is. So how do I know? I find something and I cancel and I see I reach to the same ratio. Perfect. But I told you before, if you want to see 2 fractions are equivalent, yes, of course, you can find numbers and cancel and reach to the same number, but it takes time, and I don't want you to do that. Okay, so what do you do then? You cross multiply. When you cross multiply, if you reach to the same number for the multiplication for both of them, perfect. It's the same. Means they are proportional. I call them proportional. See, is 4 over 7 proportional to 5 over 9? Okay, 4 over 7 proportional to 5 over 9. I have question mark because I'm not sure. Okay, 4 times 9 cross multiplication is 36. 5 times 7 is 35. No, they are not proportional. So the answer is no. Okay. How about the other one? Okay, so 2 over 1 over 3 equal 30 over 5. Okay, 2 times 5 is 10. 30 times 1 over 3 is 10. 10 and 10 equal? Yes. Answer is yes. Okay? So if I have 2 ratios and I have equal, I accept that if I do cross multiplication, I reach to the same number. Oh, perfect. So if one of them is missing, I can find it here. How? Okay, so I go there and I say, okay, look at this. I have $200 X. I have 2 times 500, which is 1,000. And what is X? X is something multiple. 200 is 1,000. Oh, 5. X is 5. How about here? Okay, so I have 200 multiple 5 is 1,000 equal 2x. What is x? 1,000 equal 2x. So x is 500. Oh, okay. For 5 books, I pay 500. And by 500, I can buy 5 books. Yes. Okay, so if I have a proportion, means I have 2 ratios and I agree they are equal. So if I do cross multiplication, I reach to the same number. And if one of them is missing, I can find it. Okay. So here, answer. Are they proportional? Means, are they equal? Okay. 20 times half is 10. 4 times 10 is 40. No. How about here? 3.5 times 10 is 35. 7 times 6.5 is 45, so 45.5. So the answer is no again. Okay? So, now that you learn proportions are two equal ratios, and now that you learn if you do cross multiplication, they must be equal, now you know how to find, if one of them is missing, how to find it. Now I want to show you how do I use this in order to use it in my word problems. Okay? A proportion is an equation of two ratios. Yes, I accept that two ratios are equal. In this case, one of the values is unknown and usually is x. The same as the books. You can memorize. I don't like to say memorize. You have to learn, but you can remember that and keep that in your mind. That's a good question. So the proportionality equation must be rearranged and to have x. How do I rearrange it? Okay, do cross multiplication and then solve it for x. Okay? So how? Okay. So look at this. So solve the proportion x to 9. So x to 9 equal 3 to 18. Okay? So what should I do here? Oh, I see over 9 and I want to remove it. Okay, so I multiply both sides with 9. Remember, if I multiply both sides with a number, if I divide both sides, if I do whatever to both sides, I didn't change my equation. When I do to both sides, okay? So I multiply this with 9 and also with 9. Okay, so what happened? Maybe I need more room, so I do this here because I want to show you with two ways. So x over 9 equal 3 over 18. So I do x over 9 times 9 because I want to remove 9. I have to multiply both sides. When I multiply both sides, when I divide both sides, I didn't change my question. So x is 3 over 2. Yes, x is 3 over 2. Done. You can do this way. You can also do this way. What do they say about proportion? I said you can do cross multiplication. Yes? Okay, cross multiplication. 18x is 27. What is x then? X is something that when you substitute for 18, you can find, when you substitute beside 18, you can find equal 27. Remember, you have to divide both sides with 18 because that is bothering you. That's beside x 18. If you want to find x, you have to divide both sides with 18. Okay, so it is 18x, and then you do divide both sides, multiply both sides, add to both sides, subtract both sides. You didn't change your question. When you do to both sides. So this divided by 18, and this one is divided by 18 as well. So what is the answer? 18 and 18 cancel. X is 3 over 2. Okay? Perfect. So I learned I can solve many problems with proportion. How? I make two equal ratios. Then how to solve it? I do cross multiplication and then I divide both sides with the number beside x. And done. I find the answer. If I substitute and check both sides are equal, then I did a good job. So solve the proportion 5 to x. Okay. So 5 to x the same as 30 to 50. Why did I say? I said cross multiplication 5 times 50 equal 30x. I want to find x. What is x? X is 250 divided by 30, which is 25 divided by 3. Okay? You can do that. Or you can say I multiply both sides with x because I want to solve for x. Okay, and then I divide both sides with 5. Yes, you can do that as well. Okay, so yeah. Okay, so you can say, for example, you can say I have that. That's the answer. So x is 250 divided by this. Yes, accept. Also, you can say I times both sides with x. So I have 5 over x equal 30 over 50. I have x here, I have x here. So it is 5 equal 30x over 50. Then you can times both sides with 50. So it's 5 times 50 equal 30x. Then you divide both sides with 30. So x is the same. Okay, you can answer this way. But I recommend if you do cross multiplication, it's easier. When you do cross multiplication, then you divide both sides with the number beside x that is bothering you, because you want to see x alone. You want to find x, so you don't want to see any number beside x. Okay, so now word problems. Okay, from now on, when I read the question, I really have to be careful. If Sue earns 7.95 in 5 hours, how much will she earn in this many hours? Okay, what do I have here? I have one condition, which is earning money with the same company, with the same job, but different hours. So I have two different situations with the same condition. How do I answer this question? This is done by proportion. But how? Listen. I need two ratios. Two ratios are equal because I know I need proportion. How do I arrange those ratios? I make one ratio for the first piece of information and I make another ratio for the next one. Yes. So ratio 1, ratio 2. And because I said proportion, yes, I have one condition, I have two situations, I can put them equal. Yes, that's proportion. How do I organize with ratio 1? How do I arrange with that? For ratio 1, doesn't matter, hours up or dollar up. I can say 5 hours or I can say 7.95 top. Okay, so $7.95 for 5 hours. You don't need to include unit. I did because I want to show you something. I did this intentionally. Okay, for the first ratio doesn't matter. I can do hours up or I can do dollar up. For the second ratio, however, you have to follow what I did for the first one. You have to follow what you did for the first one. So if you have dollar up, you do dollar up as well. So where do you write x? I'm looking for how much. So I write x dollar. And I have hours. So hours is down. So here hours goes down. For the first ratio, doesn't matter. Dollar up or hours up. For the second ratio, you have to be the same. So means if you have dollar up, dollar up. If you have hours down, hours down. You don't change it for the next ratio. You must the second ratio must be compatible with the first one. I also can say maybe I don't like it. I want to say 5 hours, $7.95. 3.39 1 over 4 hours dollar. Okay, so dollar hour. Okay, For the first ratio doesn't matter. For the second, I have to follow the first one. Okay, so now I want you to find x. Okay, so 7 times 95, 7.95 times 39, 1 over 4 equal 5x. So find x. Oh, okay. I want to see x alone, but I see 5x. I don't want that. I divide both sides with 5. I divide both sides with the number beside x. So it is 7.95. Oops. Times 39, 1 over 4 divided by 5. What is x then? Okay, so 7.95, 4 times 39 plus 1. Yes, so 157. Yes, 157 over 4, and then you divide by 5. Okay, so it's 7 times 95 multiple bracket 157 divided by 4 equal, and then I divide by 5 as well. So it is 62.4075. When it comes to the number, dollar, you have to round to the seconds. So it is 62.41, because you have to consider cents as well. How many cents? So it's $62.41. So if for 5 hours they have, maybe, of course it's many years ago, for $5 almost it's $8. So for this many hours is almost $60. Okay, doesn't make any sense for now, of course, I know. Okay, so how about this one? So let me check something. Yeah, okay. Yes, so I need to see this. Yeah. How about this question? In squeezing oranges for fresh juice, 3 oranges yield, means they make 1 over 3 cups of juice. Remember, this is the first piece of information. This is the ratio 1. Oops. How much juice could you expect to obtain from a bag of 24 oranges? So this is the second ratio. Ratio 2. I have one condition. I have 2 different situations and I want to find the answer. This is by proportion. For proportion, I need 2 ratios. Okay, so 3 oranges gives 1 over 3 cups. For the first ratio, doesn't matter. 3 up or 1 over 3 up. Doesn't matter. For the second, it matters. How many? Where do you write x? Up or down? Remember, must be compatible with the first one. So you need to have x down and 24 up, because you had that there. It's oranges and there's how many cups. Then you do 3x equal 24 times this, which is x equal 8. 3x equal 8. X is 8 over 3 cups, which are how many 3? 2 cups and 2 over 3 cups. Okay. Also, don't forget you need the word, because it's word problem, you need to, let me see if I miss anything for word problems. I don't think so, no. Okay, so for the first, just for the first one that I missed is Sue, and you have to write a sentence, conclusion sentence. The conclusion sentence should be informative. If Sue earns, oops, 7.95. Oops, dollar. 7 point, oops, oh my God, I think I'm tired. $7.95 for 1/3 cups. What I'm talking about, my God. Okay, so 5 hours, just mixing the question. 5 hours, she earns $62.41 for 39 1/4 hours. Okay, the same here. I can write a sentence. Okay, so if 3 oranges, so do I have the good numbers here? Let me see, this and that, and yes. Okay, so how about here? Yes, I can add the sentences at the end for both of them. If you needed 8 cups of orange juice, how much bags of orange juice should you buy? Okay, so how much bag from a bag containing? Okay, so consider it says how much bag. Okay, so what? How do you write this? Okay, so it's getting long, so if the video is very long, so it gets some maybe just confusing or something, or just conflict, so I stop here and then I continue. So this is video 2 for this lesson, and then I continue after. Thank you.